All right, this is the 4.2 Properties of Polynomial Division pre-class notes. We're going to be doing two theorems here because in class we'll teach you how to do long division and synthetic division, and these theorems are kind of tied together with that to do what we do in the next section, which is 4.3. So the remainder theorem says if a polynomial f of x is divided by x minus c, then the remainder is f of c. In other words, if you don't really care about how many times it goes into it, in other words, the quotient, if you just want to know what the remainder is, then you can plug in the 0 that goes with that factor of x minus c. Now, what I mean by that is if, and let me get my pen. There we go. So if x minus c is a factor of something, if you set that equal to 0, then x equals c is what we call the 0. Okay, so notice they're plugging in that c, which is the opposite sign of what that is. So, and I believe this first example here is the incorrect one. Yeah, so I'll mark this out. These are long division, and we're going to do that together in class. So we don't want to do those. So those show up on the in-class notes as well. Okay, so the remainder theorem is right here. So it says if we want to figure out the remainder of this, if we were to do the division, we just plug in the 3 since this is already solved as c equals 3. So f of 3 is 2 times 3 cubed plus 4 times 3 squared minus 3 times 3 minus 1. So that's going to be 2 times 27 plus 4 times 9 minus 9 minus 1. That's 54 plus 36 minus 9 minus 1. That's going to be 90 minus 10, or 80. So that means that this is the remainder when the function f of x is divided by not 3, but c minus 3, or x minus 3. We like to write it as a factor. And let me erase that because that didn't write correctly. So divided by x minus 3. You know that this is the 0 that goes with that because if you plug 3 into this factor, then it makes it 0. Okay, so let's do another one. So if we're looking for the remainder here, so we would do f of negative 2 equals negative 2 to the 4th plus 3 times negative 2 squared minus 12. Negative 2 to the 4th is positive 16 plus 3 times 4 minus 12. That's 16 plus 12 minus 12. The 12s cancel, so we just get a remainder of 16. Now, the factor theorem says that, and I don't know if that one was listed here. Yeah, the factor theorem says that if the remainder comes out to 0, then you know that this factor x minus c actually is something that divides evenly into your function. So if you get a remainder that's not 0, you know you don't have a factor. So this is just showing that this one is a factor. So we should see a remainder of 0 this time. So 2 to the 3rd plus 2 to the 2nd minus 11 times 2 plus 10. That's 8 plus 4 minus 22 plus 10. That's 12 minus 12, which equals 0. So notice that that means x, since this is positive when it's over here, when you solve it back over, x minus 2 is a factor of f of x. And that's going to be really powerful for us in the next section in 4.3 on Thursday, because we will be able to then say, okay, if this is a factor, then we can pull it out. And we'll be able to factor these larger polynomials. So let's look at this next one. So we're going to see if this one also is a remainder of 0, which would make it a factor. So we would do 2 to the 4th is 16, minus 3 times 8, minus 2 times 4, plus 10, plus 6. That's 16 minus 24 minus 8 plus 10 plus 16, or sorry, plus 6. I was already adding them in my head. So plus 6. All right, so this is 16 minus 24 is negative 8, minus 8 plus 16. So that is definitely negative 16 plus 16, which is 0. So in this case, x minus 2 is also a factor of that f of x listed there. And that's it. That's all that's in the video. So two big theorems. If you plug in the c equals the number, so you plug that number into your function, it tells you the remainder if you had divided by that specific related factor of x minus the number. And if you get a remainder of 0, then you know that the actual factor goes into your polynomial evenly, which means we can factor it out. And that's it for this pre-video.